The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
Okay, good. Is everyone ready? Let's get started. Okay. Hello, this is Open Source Tools for Game Development. My name's Ryan. I'm just going to give you a few notes to get us started. Can you all hear me okay? Because I sound like I'm getting a lot of echo. Is it good? Okay. Slow it down. Unlikely to slow down. Okay. If you can't read these, just look at me waving animatedly over here. It'll be much more entertaining. Okay, a few notes. If you're tweeting or using Identica or something like that, please use the hashtag self2013 so we can find you and make fun of your grammatical mistakes later on. If you have a question or a concern or a complaint, just interrupt, just raise your hand or yell it out, and I'll change my talk as appropriate, so whatever goes from there, you know. The slides for this are up right now at that URL, which is iculus.org/self2013. But you know, you can just follow along. They're also up on the screen here. Okay, and one final note here is a quick confession. I already gave this talk before, so if you heard this or you saw it on YouTube or you were in Chicago that day with the three other people, then there's going to be a lot of repeat stuff. But I've made a couple of updates, but other than that, sorry if you've already heard this. Okay, so who am I? My name's Ryan. What I do for a living is I develop video games. I port them to Linux, I port them to Mac OS, I port them to your toaster oven, stuff like that. I like to think of myself as a hacker in the positive sense of that term. And when I'm not porting games, I'm building tools to help me port games and help other people write games on Linux and write games on platforms other than Windows, which there's nothing wrong with Windows. Well, there's something wrong with Windows, but I like the fact that I didn't really come here to push Linux. I came here to push everything, and whatever works best for you, you should be able to use it. And if we can build tools to make that easier, then that's what I'm here for. If you want to find me, I'm on Twitter at Iculus. My email address is iculus@iculus.org, and you can still look at my resume if you're really bored, but I brought pretty pictures about my resume in the meantime. You might have heard of a company called Loki. I used to work for them porting games to Linux commercially. Then I went on and worked for people like Activision and EA and Epic Games. I did Google Earth at one point. I worked for Valve, and now this is my most demanding client. That's my 16-month-old daughter. But enough about me already. This is a talk about tools and libraries and such for open source game development, but just to be clear, this is not a complete list. There are literally thousands of really good pieces of code floating out on the internet with nice liberal open source licenses and free software licenses, and I just picked out a few that I like, a few that I've used directly, or things I've heard really good things about if I haven't touched them directly. But just understand that further research is definitely recommended, and if you find something really great, email me and I'll add to the talk next time I give this. Other than that, we're going to jump right into this. So, okay. First thing we're going to talk about, if you were in my speech last night, I talked about SDL 2.0. This is the number one thing if you're doing open source game stuff, or you want open source tools for your games. I should probably say that. This isn't if you're running a closed source game, I'm not going to judge you. Everyone else here will, but we're not. You can do what you want. I'm just talking about open source tools you can put into your game, regardless of how you distribute your game, or your source code, or your binaries only. But with that said, okay, SDL, it stands for Simple Direct Media Layer. I'll go through this very quickly, because I see some of you were in this talk yesterday, and you're already sick of hearing about this. Okay, Simple Direct Media Layer, it's basically, think of it like DirectX, but cross-platform. It gives you video, audio, input, joysticks, force feedback, a little wrapper over like how to spin a thread so that you don't have to have all these if-defs in your code for different things. It works on lots and lots of platforms, and it's easy to use. And you say it's easy to use. That can't be true. I'm going to give you an example. How many of you have worked in Direct3D before? That poor guy. You need a new job if you're doing this for a living. We can find you one. It's okay. Direct3D is not fun. But I'll give you the simple example. Let's say you're working on Windows and you want to use Direct3D to draw some stuff to the screen, and you have, you want to get that window on the screen. We're not even talking about drawing it. You just want to get that window on the screen so you can draw. So I brought some example code to show you how this is done on Windows. And this is not made up code. This is literally a cut and paste from the Microsoft tutorial on how to do this. So this is pretty much what everyone cuts and pastes when they start a new game with Direct3D. Okay, so I'm sure you all can read that. So I'll put the highlighter up here. Let's see if we can get that. Come on, Go on, highlighter, where are you? There you go, okay. So you want to get your window class, you got to register it, then you create a window, and you make sure that it's updated and not shown on the screen, and then from there, oh wait, we got a little bit more we got to do here, and you want to get in here and enumerate all the direct 3D adapters, find one that's at your resolution that you want, your depth support, and you got to go from there, and then that's okay, so then you go, oh wait a minute, we need to make sure it can do vertex processing, and this goes on for a long time. Oh, and also, if you couldn't see this on these slides, because I know that the font's a little small here, you might have seen these comments all over this source code. To do, respond to the failure of function name here, all over the source code. And we frown on that. Because that example becomes much, much longer if you actually do error handling and clean up when things fail. And for what it's worth, it's not like, well, that could fail, but it never does. That's exactly where it fails, where you find out you don't have a 3D card in your machine. Believe it or not, those still exist. Or they have the wrong version of Direct3D. Or you just, on the latest version of Windows, you just don't have access to the GPU or something like that. That's where it fails. You need to check for all those cases. So, okay, fine. Let's talk about SDL. The way you would do this with SDL, if you want to do an OpenGL thing, looks something like this. You ready? This is the complex version. Here you go. You tell it, I need video support, get me a window on the screen. Make it full screen, give me OpenGL so I can do 3D stuff, and you're done. Now, to be fair, I didn't have error checking either. But you can add 2 lines of C code to that if you really need it. So, or an ampersand, ampersand, a logical and. That example was SDL 1.2. It's actually a different function call in the new version. We're just about to ship SDL 2.0 and literally in the next few days. We're already shipping games with it, but we're actually finalizing like a bug fix. This is the exact final original 2.0 release. But the example I just gave you said, SDL set video mode. The new one's SDL create window and does some other stuff from there. But a lot of the basic functionality hasn't changed between 1.2 and 2.0. You get your video, you get your audio, you can put stuff on the screen, you can put stuff to the sound card, you can get events like someone wiggled the mouse or somebody closed the window or whatnot. You can get timers like how many milliseconds have gone by. You can get joysticks, who's moved the game controller, who's plugged the game controller in and stuff like that. And just a nice layer over things like creating threads or loading DLLs and stuff like that. Things you can do on almost any platform, but there's just, rather than have a bunch of if-defs in your code for one line for Windows, one line for macOS, one line for this, you just have one function call that works on all of them. Which has been the real benefit of SDL, is that you end up with this program that you've written that uses SDL. You start looking at platforms you've never thought of before, and you compile your code, and it just works. Because as far as your program's concerned, it just wants to say create a window on the screen. It doesn't care that behind the scenes SDL is talking to Cocoa on macOS and the Win32 API and X11 and in the future Wayland or Mir or whatever. So it handles all that for you. It's really nice. Now we're just about to ship SDL 2.0, which is a lot of the same functionality as 1.2, but it removes a lot of limitations. Like the example I gave you there was, here's how you get a window on the screen, SDL set video mode. You can only have one window in the older version of SDL because that's all we ever needed. We're making games. You put a window up on the screen and you're done. But the new version will let you do things like multiple windows because you might want to have something on different displays. Like you have, for example, the iOS port of it can have this screen here, and it can also control that projector at the same time because it can see them as 2 separate displays, et cetera, like that. Speaking of which, we've added things like Android support, iOS support. We're working on getting Raspberry Pi in there. We're doing, we're looking for weird esoteric platforms that we can make this run on. We had to drop a bunch of platforms because nobody has macOS 8 anymore, things like that, I hope. If you do, it's time to upgrade your machine. But it's like probably no one cares about the Dreamcast port anymore, so we pulled that out. But, we still have all the major operating systems, all the major mobile devices you care about. We still have BIOS support, stuff like that. So this is worth looking into. It's at libsdl.org. I should say that link I gave at the beginning, which will be up again at the end of the slides, has a link dump of everything I talk about here. So if there's something you're interested in, you can just go to that site and find, click on the ones you like as a shopping cart kind of thing. Okay, let's move on from there. So that's SDL, which gets you most of the stuff you need. But one problem, is those that were in my talk yesterday found out, is that SDL will let you play sounds through the sound card, but they want you to do all your own mixing and spatialization and all that stuff. They basically just want like raw like waveform data is all the SDL wants to play back. So it's really hard if you have to write your own mixer just to play some stuff. So usually we tell people not to use SDL directly. We tell them to use OpenAL. If anyone has used OpenAL, raise your hand. All right. Oh, right. I know where the game developers are in the house. Good, good, good. OpenAL is an audio system. It's much higher level than what SDL gives you for audio. In fact, you could build an OpenAL that talks to SDL to actually play sound, but does all the 3D math and stuff itself. It's 3D positional audio. It's cross-platform. Chances are you have a device that has OpenAL support right now. If you have a Windows machine, there's a free download version of it. If you have a Linux box, you probably have it installed by default. If you have a Mac that's greater than macOS 10.4, you have it installed on the Mac by default. Apple ships their own version of OpenAL. If you have an iPhone, you have OpenAL on the device by default. In fact, that's how Apple tells you you should make video games for the iPhone, is to talk to OpenAL. So this is an API that you can use in lots of different places. And for the places that you don't have it by default, there's a very nice version of it called OpenAL Soft, which is just an open source LGPL library that runs on pretty much any platform you can try to compile it on, and will do the right thing and give you, surround sound and all that magic good stuff. It's really easy to use. We'll talk about that in the next thing. But it's also good for 2D games. There's been a number of games that I've shipped that were, like platformers and stuff like that. And we still used OpenAL for it because it was really easy to get the audio up and running in it. We had when I first wrote this talk, there was a game I was shipping called Avedon, which is a role-playing game. I don't know if anyone's played it in here. It's up on Steam now if you want to buy the Linux version of it, as of last week. It has, on Windows, it used direct sound, and it would just set up some buffers and play them and blah, blah, blah. We need to get this up and running really quickly because it was going to be in a humble bundle, and we got this project going at the last minute. It was like, we need to get the audio running. 60 minutes later or so, we had an OpenAL backend and it running perfectly. So it's really easy to just drop into something. And we literally ripped out one piece of code and put in a new one, and it was fantastic. And I'll give you a rough idea of how this looks. So I give you the complex SDL example. Here's a rough equivalent in OpenAL. I don't know if this is going to be easy to read, but you can see the bright letters over here. ALC open device. If anyone's ever used OpenGL, it's the same thing. Everything has an AL in front of it. That's a function call. You open a device, you create a context on that device, you make it current, and then you are ready to play sound. It's really that simple. Also, if you'll notice from these slides, I check for errors, so let's hear it from me. Okay, so if anyone's ever used OpenGL, OpenAL is going to be incredibly familiar to you. When we first designed this API at Loki Games and Creative Labs, if anyone remembers the Sound Blaster, somewhere in the late 90s, they put together the original version of this API. And what they were explicitly trying to do was make it feel like OpenGL. So a lot of the conventions are the same. The coordinate system is the same, which is really nice if you're running a game that also uses OpenGL, because you just say, my dude, draw him over there. And then the thing the dude is saying, play it over there, and it's good. You want to think of this as a collection of objects. You have one listener always. Think of that as like the microphone. Like, this would be your listener, this thing right here, if this was OpenAL. And you have a handful of sources, which are things that are making noise. Like if that guy started like singing, Don't Cry For Me, Argentina, or something like that, then that would be a source playing it. You have a handful of those around the room that are making noise, and then you have many, many buffers, which are audio sound effects. So this guy over here is singing a Madonna song. The actual song itself, the content, if that was a WAV file, that's a buffer. So, and the last thing is not actually an object, but you can queue those buffers if you have like streaming audio or something like that. So, so basically you have one dude listening, a bunch of dudes talking, and they have buffers, which is the sounds they're making. That's basically all you need to know about OpenAL. And there's a couple other features, and you can get into fancy things like the Doppler effect. Like, how a car sounds like the pitch is changing as it zooms past you? That's the Doppler effect. OpenAL has, a setting for that, and things like that. But if you just want to move things around, it also works really nice as a 2D API. You can just be like, I just need to get some sounds and play them. It's good as a simple mixer too. So I highly recommend it. We're going to move on from that though. Yes?
Any spatial consideration for like multi-point speakers and things like that for OpenAL?
He asked if there are any spatial considerations for it. OpenAL takes care of all that for you. It assumes that you're playing in a 3D land. If you're playing a stereo sound, it won't spatialize it because it assumes you meant to have left and right. But other than that, you just say, this source is moving over here and the listener has not moved. It knows to do distance attenuation and make it quieter as it gets away, and move it between speakers as he moves behind you and stuff like that. And most OpenAL implementations will handle surround sound, including OpenAL soft, the open source one. You can give it 8 speakers around you in a circle, and it will know to move it to the correct speaker as that source is moving around. So, and you don't have to worry about the mixing of that. You just say, it's over there, I'm here, make it sound right. Which is really fantastic. All right, we're going to move on from sound. I know I'm talking really fast. We have a lot to get through here. So if you have any questions, ask me to repeat myself. I don't mind. I won't be offended. All right, let's move on from audio. Let's talk about file management stuff. Who's used SQLite? A lot of you have used it, and if you haven't used it directly, you've used it and you don't know it. Is Richard in the room? No? The guy who wrote SQLite is actually giving talks at this conference too. So he lives in Charlotte, much like I do. Hope I didn't give away any secrets there. Anyway, so SQLite, for those that don't know, it's what it sounds like. It's an SQL engine, but instead of being like, I know everyone here has had trouble with MySQL. That's why there's 15 different talks about it here today. But you know, this is not a client-server thing. You're literally writing to a binary file on the local file system. It's not meant to be used for servers, although you could use it for that if you want to. It's meant to be used for one person on their machine that needs to store relational data. And that sounds kind of strange, but there are a lot of applications for this that you wouldn't think of. It's really, really hard in 2013 to buy a computer that doesn't have SQLite pre-installed on it. If you have, let's see, a Linux box, it is installed by default. If you have a Mac box, it's installed by default. If you have an Android, it's installed by default. If you have iOS, it's installed by default. If you're using Firefox or Google Chrome or Safari and probably Internet Explorer, though I don't know for certain, you have a copy of SQLite in that. The reason this is so great is that it gives you, full SQL support. You can just say select blah, blah, blah from blah, 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 and it does it. Writes it to a single file. And the entire thing, if you want to use in your project, one C file. You just drop it in and compile it with all the rest of your code. And it just does the right thing. And like I said, you're already using it. Something that you're running on one of these laptops right here is already talking to SQLite. Now, this is important to note. People say, could I use this for like some massive scaling thing? And people have used SQLite for some really audacious things, but this is the most important quote you need to know about this. SQLite does not compete with Oracle. It competes with fopen, says the primary developer of this. You shouldn't be writing an INI parser, and you probably shouldn't be using XML. I know that's probably sacrilege, I'm sorry, but XML really kind of sucks. But if you have to do config files, or you need to have some kind of sort of data structure for your game or something like that, that is a little bit more random than like a tree would give you, or some kind of obvious hierarchy, you should be using SQLite. It gives you a definite, well-defined file format. It gives you a very fast, optimized piece of code. And even if you're going to write something like, I'll just write a comma-separated, a CSV, a comma-separated values file, and I'll parse it out myself, you're going to put a bug in it. It's going to happen. You write an INI file parser, you're going to put a bug in it. String handling in C and C++ kind of stinks, so sooner or later you're going to make a mistake. It's better to go with the thing that's been developed in the open for many, many years and debugged and optimized and has lots and lots of money behind it, because a lot of companies need this to be debugged and optimized and improved all the time. So I recommend going for it. All right, while we're talking about files, if you need something other than SQLite, which you probably will, but I have a project called PhysicsFS, and latent self-promotion. This is my project. I wrote this one. It's awesome, as the slide says. You can use it so that you can also be awesome. The basic gist of this is that you have a virtual file system, and this is not an unusual concept. You have this already if you're using Linux itself. You can mount directories on top of directories and stuff like that. But I used to play a lot of Quake 3 Arena. Has anyone ever played this game? All right, let's hear it. I love that game. The way that would work is you would give it would start up and it would say, okay, here's a directory where my data files are, and here's a bunch of zip files that are mods to the game or patches to the game. And some files might be on the CD-ROM drive where the game disk is sitting, and this might be the user's home directory over here, which has some extra configuration files and stuff. And it would mush all this together, so then after that it could just simply say, hey, I have this one tree, whatever was last in, whichever zip file had the alphabetically last name wins whatever's in it. So you could say, and you just talk to that and say, give me file, level 1.map or something like that. And it would say, okay, of all the zip files we have, this is the latest version of level 1.map. And it doesn't really care where it came from. Or you don't care what zip file it came from directly. It handled all that for you transparently. And I love that, so I made an open source version of that that you can drop into your game. It supports zip files, as you might expect, but it also supports lots and lots of other things, Doom WAD files, and the group files that Duke 3D supported, and 7-zip files and stuff like that. So you can just basically say, you can use it for many things. You can, one of the best benefits to it immediately from the guys that wrote Quake was that as they put out a new patch, they just said, what files changed? They zip them up, and they would give you that zip file and say, just put that zip file in your directory. Don't unpack it. Don't try to overwrite anything. Don't try to update anything. This is just, you have the latest data now. Just by putting this in there, it'll figure out what to override that was here earlier, which is really useful. PhysicsFS is very concerned with security and functionality and flexibility, which is to say you can't write outside, you're given one write directory, which is usually somewhere inside the user's home directory, like where their personal configuration files would go. PhysicsFS, as long as you're writing only through PhysicsFS, will never let you write outside of that directory that you asked it to. Like if, some crazy KRAD hacker says, oh, I'm going to put a bunch of parent directories in the path I try to open, it'll notice that and be like, nope, can't do it. If you try to read through a symlink, unless you've explicitly told PhysicsFS that you're accepting symlinks, it'll cancel those file reads. It won't let you get through there at all. And flexibility, the new version of this that's coming up is, it's got all sorts of crazy interfaces for saying, I don't want a zip file, I want to have a zip file inside a zip file, or I want to read this off a HTTP server on the fly and stuff like that. And it's all nice and abstracted, and you can read data out of memory and stuff like that. So that's cool. It's good. You should use it. I recommend it. That thing is about 10 or 11 years old now. I think I started in 2001. So there's a lot of development that has gone into this. This is not a new project. But I should point out the disclaimer here. Look, I know that despite the name, this has nothing to do with physics. The original project this came out of was a physics engine, and this was the only good piece of code in it, so we threw the rest of it out and made this a separate library. But while we're talking about physics, let's talk about that briefly. Because lots and lots of games, especially in modern times, need physics. They need to be able to say, I'm going to drop this object, I need it to bounce realistically, and I need it to respond to a, active environment. And there are projects that do this. There are open source projects that do this, and they're of various quality. I've picked 3 here. There are probably others, but I'll go through these very quickly. I should say that I've worked with some of these, and I'm not very good at physics. My math is incredibly weak at this, but I'll try to explain this the best I can. Open Dynamics Engine is the oldest of all 3 of these, ODE. It's been used in a lot of things. It's been used in some commercial stuff too, like there's a first-person shooter named Stalker that used it. It's definitely up to the task of doing rigid body physics. It's a little slow, and it's not very well maintained at this point. But it's a workhorse. It can get things done if you need it to. Box2D is a much simpler one. Who here has played Angry Birds? I can't believe every hand didn't go up. It's not 2011 anymore, I guess. Angry Birds uses Box2D. When you shoot a bird from the slingshot, that's all being calculated through Box2D's physics, so I'm told. And as the green pigs roll away and stuff like that. That sounds absolutely delusional if you've never played Angry Birds, though. Anyway, but the important thing about Box2D is it's literally 2-dimensional. It expects that you have a flat plane and you're dropping things onto it, like say Angry Birds is. It doesn't deal with anything like the box moved into the screen or anything like that. Another game that uses that is Limbo. I don't know if anyone's played that game. If you haven't, you should download that tonight and play it. It's really fantastic. But the physics in that, because it's a 2D game, it's a side-scrolling game, Box2D was a good, simple, fast thing for them to use for that, so they did. And other things have too, but I don't know off the top of my head. The hotness right now is this physics library called Bullet Physics. It seems to be, when I've asked, I have not used it myself, but when I've asked other developers that have used it, they tend to prefer it over Open Dynamics Engine, over ODE. It seems to be faster, better maintained, more optimized. It can take advantage of things like, SSE and stuff like that, the vector operations on your CPU and stuff like that. And it seems to be just a little bit better at what it does. It's certainly the fastest of all of these for the complexity. Now there's lots and lots of closed source physics engines too, but these are the open source ones, and these are worth looking into if you like it. Okay. Let's go back to audio for a second, or at least audio decoding. Ogg Vorbis and Speaks. This is all you'll ever need for audio in your game. You shouldn't be shipping WAV files, they're way too big, and you shouldn't be shipping MP3s because they're way too expensive. Every time maybe not you because you don't care if you're sued, but anytime somebody ships something that can play MP3s, technically they owe a royalty to a company which I cannot pronounce the name of, but it's something like Fraunhofer or something like that. It's a German word, I think. But let's say every time you buy an iPod or something else that'll play MP3s, every time you download iTunes, somebody owes this company 25 cents for that download, which in the cost of an iPod, that doesn't mean anything. So it's like, okay, no problem. But as an individual independent game developer or a small game shop, that should mean an awful lot to you. So you should absolutely not use MP3s under any circumstances, regardless of what libraries you have available to you. Especially because there's ones that are perfectly good, such as Ogg Vorbis. Does anyone know where the word Vorbis comes from? Has anyone read this book? No? Okay, Terry Pratchett. He would appreciate your business. Go get a copy. Vorbis is a character in it, I think. And Ogg is a geek term for do something really hard, which I think is nice. So, anyway, let's talk about this. Vorbis does compressed audio data. More or less, it is competitive with MP3 in terms of quality and compression, which in itself means that you shouldn't be using MP3. It's also open source. I believe it's BSD licensed, like literally a BSD license on it. It's a couple of C files. You can compile it into your program easily enough, and you just go from there. Speaks is the other end of the spectrum. If you're thinking of like higher quality with like MP3 or Ogg Vorbis or something like that, the low end of that is Speaks, and there's a different reason for that. Speaks puts out really, really small, low quality files, and it's great if you're doing voice over IP. To give you an example, if you have I did the math on this, and I could be wrong about this, but if you have a 28.8 kilobit modem, you can do full duplex audio, hear and speak at the same time with Speaks, and still have a little bit of bandwidth left. So like this is what you want to be using if you're trying to send somebody talking over the internet. It's optimized for voice too. If you were to use Ogg Vorbis on that, it will also compress voice in the same way that it compresses anything, but Speaks is very good about saying, well, the human voice uses this range, so cut out all the rest of it. It's patent unencumbered. In fact, both of these, they were very, very careful about patent research and making sure they were not stepping on anyone else's patents. And they're both BSD licensed, so you can use it itself and not have to worry about being sued, and also not worried about being sued. Both of these are at ziff.org, which I think is some kind of fish. These people love weird names. But both those projects and many other ones, including one I'm going to talk about in a moment, are at xiph.org. Okay, but a pro tip for you, when you use Ogg Vorbis, the thing that actually does all the decoding is called libvorbis. You don't want to use that. It's really, really hard. It's incredibly low level. It wants to talk about packets and page sizes and things like that. It's not very nice. What you want to use is something else that ships with it called libvorbis file, which handles all that stuff for you. It does all the heavy lifting and worries about all that. So you say, I have this data. It's a .ogg file. Give me back some uncompressed data so I can work with it. And you just keep feeding it stuff, and it feeds you stuff back, and you don't have to worry about the finer details of the file format or anything like that. That ships in the same package. Just make sure you get the right library when you go looking for that. Okay, let's see. So that's fine. So that's audio, and we talked about video. Let's talk about motion video. While we're talking about things that have the word Ogg in front of them, let's talk about Ogg Theora. Has anyone used this? Good. It works under the same basic principle as Ogg Vorbis does. In fact, it uses Ogg Vorbis for the audio stream in your video file. But you run into the same problem with video that you run into with MP3s, that MPEG and this format and that format, and I don't know what the stance is on WebM right now, but all the popular formats right now have some questionable patent encumbering, or they have somebody that wants you to pay some money for it, or they won't give you source code to their implementation, or whatever like that. Ogg Theora is that same answer right there, and it's also very simple in that you can drop it into your project and just compile it and not have to worry about third-party libraries and stuff like that. More or less, it's the same principle as using libvorbis. But while we're talking about funny names, does anyone know where Theora comes from? Anyone remember this guy? Theora was a character on this show. I guess it's that 80s nostalgia just permeates all their projects. Okay, so This is, like I said, Ogg Theora is the video equivalent of Ogg Vorbis. It's to video what Ogg Vorbis is to audio. It's originally a company called On2, had a codec called VP3, which was not covered by any patents, and they handed it over to Zif.org and said, we will not sue you, we're donating this code to the public domain, you do not have to worry about enhancing this. So they built on top of that, and that's where it started. Yes, question?
It's part of the HTML5 spec then, too.
Is it actually part of it? He's saying it's part of the HTML5 spec. I didn't know that. There was some fighting about that at one point, but you will get more. In fact, since you mentioned that, if you take a Theora file and drop it, just drag and drop it from your desktop into Google Chrome or Firefox, it'll just start playing the video. So, I mean, your web browsers are already starting to get support for it. Safari and Internet Explorer don't yet. Hopefully they will at some point, but like I said, there's still some fighting about it. Yeah, it's going to be a fight for a while. Anyway, but web standards are not important here because you can do whatever you want when you ship your own code and data. So I'm saying this is good to ship for that. It'll do HD video, like what we would call 1080p. It can do that level of video at a decent file size and decent performance. And again, no patent worries, no copyright worries with the license, and that's at theora.org. Oh, but I have a pro tip for you about this too. There is no equivalent of libvorbis file. The thing that says, I give you data, you give me data back. Ogg Theora does not ship with anything like that. They want you to get down dirty at the low level, at the packet level, and do all that tamp testing, and it's awful. I don't recommend it. But I have some more blatant self-promotion. I wrote something so you don't have to. It's something called Theora Play, which basically just, you say, I'm giving you data, and it'll split it up into multiple threads and use libtheora behind the scenes across multiple cores to give you as fast a processing as possible, and then hand you back data without much fuss. And they'll give you, here's your audio stream, here's your video stream, do what you want with it. That's at that link. You can get it at the end if you want it. Enough about video. Let's talk about lower level stuff, because I got to tell you, I'm not a graphics guy, and I don't really think of myself as an audio guy, but I do always at my heart think of myself as a programmer. So let's talk about scripting languages for a moment here. And I guess I think of myself as a Linux hacker too. So let's talk about scripting languages for a moment here. Who's used Lua? I feel like it's the same hands going up every time. This is a very specialized talk. Who here's used JavaScript? Okay, Lua is JavaScript with all the shitty parts taken out of it. There's nothing left. To be fair, JavaScript is not a bad language either if you didn't have to deal with 15 different web browsers that did different things wrong. The language itself is very interesting. Lua it looks a little bit like BASIC, don't get nervous. But it does the thing that JavaScript does very well, that everything is a table, or I should say everything's a hash table, where you give it just blah, blah, blah array of another object, or of a string, or of a number, and it does the right thing. And you can do some incredibly powerful things with that very quickly and very simply. It compiles down to bytecode if you want to, so you don't have to ship your scripts if you don't want to, although there's really no reason not to, because the full compiler and runtime library for Lua compiles down to like 150 kilobytes. If you were compiling it yourself, if you didn't use a system library. Although this tends to ship on everything too, for just this reason. But yeah, it's a bunch of C files, drop it into your project, compile it as part of it. And another thing that's very interesting, there's a lot of scripting languages that I like a lot, such as Perl and Python and Ruby, but they're really, really hard to embed in your project. You pretty much have to count on them being on the system, or you have to do an enormous amount of tap dancing to ship your own. And that tends to be like this, you get this massive Python runtime library with it that you don't actually need, and it's just messy and stuff. Lua is very, very simple to ship and embed in your project. It's literally ANSI-C, and I know everyone says that, but I mean literally it will compile with nothing but an ANSI-C compiler. So if your compiler is from 1989, Lua will still build, which is good. It's also, unlike Perl and Python and Ruby and everything else, incredibly easy to jump between C or C++ and Lua, and jump back and forth between each language pretty quickly with a minimum of fuss and without having to do all kinds of ridiculous, ugly things. Lots and lots of games. Oh, I have a slide for this. Lots and lots of games ship with Lua. Chances are it's shipping in a game you've played and you don't even know it's in there. World of Warcraft has always been the big popular example of it. In fact, they exposed Lua so you can write your mods in Lua for World of Warcraft if you're still playing that. Crysis has used it for many years. It's been in games as far back as, the first thing I saw it in was a game called Grim Fandango, which was like mid-90s. It's been around for a long, long time. And almost every AAA game now is shipping with something that looks like Lua. give or take. Okay, I covered all these other things. It's crazy powerful and yet efficient. Okay, moving on. These are all libraries you've all heard of if you've ever, had to build your own packages or something like that. Is anyone here, what are we all using? Are we Ubuntu users? Fedora users? Slackware users? Arch, okay. Just yell it out. What are you guys using? I've never seen Arch. It's a hodgepodge. There's a whole bunch of things. That's what I love about these places. Good. Well, everyone has seen this package sooner or later. zlib, when you have a gzip file, the compression is done by zlib. Everyone's heard of it. libpng and libjpeg do exactly what you think they do. They uncompress and create PNG files and libjpeg files. These are old, ancient open source libraries. They've been around for 1 million years. Everything in the world uses them. If you need compression, you're probably using zlib because it's fast and cheap. And every web browser, everything ever that's done graphics probably links to these two libraries. But here's my pro tip for you. Don't use these libraries. They suck. I'll give you some alternatives. I'll tell you why they suck too. Let me go back a slide here. zlib has been around for 1,000 years, like I said. It still has 16-bit DOS support in the source code. That's not a joke. It really does. And I'm somewhere out there. I'm sure there's somebody with an embedded processor chip that's still like an 8086 that they need the 16-bit segmented zlib to work on it. And I don't disrespect that, but zlib is an incredibly large piece of code with a lot of really weird files for things like Amigas and Mac Classic and things like 16-bit DOS. And there's a lot of if-defs for there's a lot of things you take for granted once you have a 32-bit address space that people that ever had the misfortune of writing things for DOS still. It keeps them up at night that, there could be a zombie apocalypse and all that's left is like one DOS box left, and nobody wants that. Okay, but libpng has a header file that ships. It's a public header file that has a bunch of if-defs in it, and depending on how those defines get set, the thing becomes binary incompatible in very quiet ways. So, for example, if you build your own copy of libpng, and you have the header file and you compile against it, and then you ship your program, and the Linux distribution you're using has their own libpng on it, but they used slightly different if-defs there, your program will crash in weird ways and you will never know why. It's because the size of structures have changed and different behaviors have changed and stuff like that. And libjpeg uses setjump, which just means it's evil. You shouldn't ever use that program. Actually, so does libpng for that matter. If you don't know what setjump is, don't learn C. You're leading a happier life. But it's a bad design decision from old school Unix that has haunted new school Unix for many years, and those are still culprits of that. So don't use them. It's bad. I got better solutions for you. Don't use those libraries. Okay, the first one up is STB wildcard. There's a guy named Sean Barrett. He's a ninja. I don't know what T stands for, but those are his initials. He works for Rad Game Tools right now. If you've probably heard of some of their things if you're a game developer. They do Miles Sound System and Granny and Bink and stuff like that. He works for them. He's working on none of those projects for them, but occasionally he writes an incredibly useful piece of code, and his employer, Rad Game Tools, lets him release it in the public domain. I don't mean under an open source license, literally like the here you go license. It's whatever you want to do with it. So it's in the public domain. And he's written JPEG decoders and PNG decoders and BMP decoders and an Ogg Vorbis decoder and other things like that. They're all almost universally a single header file that you compile as C code, and then also include later when you want to actually use it. That's about the simplest form of drop it into your program and go you can get. Do you have a question?
Well, has he written anything that goes the other way? For compressors?
I don't know, because I don't usually use... he asked if there was anything he's written that goes the other way, like compressing stuff. There might be stuff for that in there. Generally speaking, I'm worried about uncompressing it. You can use whatever tool on your machine. It's what you're going to ship out that has to be fast in the field. But you can look into it. He's got an enormous amount of interesting stuff on his website, and animate a GIF of him juggling. So yeah, most of these things you can find an equivalent there, including a zlib equivalent, but I got one that goes one better than that, called MiniZ. It's 300 lines of C code, and it implements all of zlib, which, just to give you an idea of what I was talking about, that there's all this extraneous stuff for 16-bit DOS support and stuff like that. You can re-implement that entire library, and literally the same API. You can link against this instead of zlib, and it won't know the difference. 300 lines of C code. It's faster than zlib, too, by the way. And other features like that. You don't have to use the zlib interface. They have a different one too if you prefer, which doesn't fall in the 300 lines of code. But that's incredibly good. That's not even like copy this file, and that's like cut and paste that into your file. And it's also public domain code. It was actually inspired by Sean Barrett's stuff, so I highly recommend that. I've been looking through projects that I've done that use zlib and been ripping zlib out and just dropping in 300 lines of C code and feeling much better about it. You know, there's something really satisfying about ripping code out of something. It's much more fun than adding code, I've found. I don't know. Demolition, you know. Okay, let's go on to networking real quick because I'm getting behind schedule here. There's a networking thing called ENet. Networking is incredibly hard. If you've never done networking, I don't mean like set up a web server or make sure your Wi-Fi card works or something like that. I mean talking about like UDP packets and worrying about like, I sent this packet, it may not get there, it might get there later than on this other one I'm about to send, and you know, they might reply, but if they reply, that means they might be waiting for this, that I might, you can melt your brain trying to work your way through some UDP programming stuff. ENet does that for you. It's a really simple library. It hides the minor differences between WinSock and BSD sockets and stuff like that. And it also gives you things like channels. So you can say, like, I have different things I want to send to this other machine. Like I have the game data's going here, I have a voice over IP stream, they have a chat room thing going. You can just assign them different channels. It'll send all the packets out, figure out what order they got there in, reassemble them, say, I didn't get this, but I know it's I don't know if they got this, but I know it's a reliable thing I need to get there, so keep resending it till you know it gets there. It handles all that heavy, ugly lifting for you. And it's a nice, simple, clean library. If you're doing networking at the low level, this is what you should be talking about. This is an incredibly good library for that. Let's talk about graphics again for a moment. If you're doing 3D graphics, you have choices. You can do GLSL for OpenGL, or you can do what's called HLSL for Direct3D, and the two are slightly incompatible. Like they kind of look the same, but not enough that you can compile them. So if you want to run programs on your graphics card, like this is a little higher level. This isn't Super Mario Brothers. This is, you know, Unreal Tournament, you know, whatever, something like that. What MojoShader will do for you, blatant self-promotion, I wrote this too. MojoShader will take a Direct3D shader, because they compile down to a bytecode. Microsoft tools will make bytecode out of them. It'll take that and it'll convert it into an OpenGL program on the fly. So you just hand it your stuff from Direct3D, it gives you GL shaders, and you just go with it. You just draw with it, and that's cool. We're working on a full HLSL compiler so that you don't even need Microsoft tools to make the bytecode. We already can do shader assembly and preprocessor stuff, so we're making progress on it. I found out that writing a compiler is incredibly hard and humiliating, but you know, it's been worthwhile too, so that's in progress still. You can get that off my website. Okay, we're getting near the end of the talk now. And I know you're all sitting here saying, you know, you've talked to me about a bunch of libraries, but this talk was called Open Source Tools for Game Development. And I'm a programmer, so I think of the libraries as tools, but if you want literal tools, like things that you click your mouse on and stuff like that, I have a few of those for you. So I'm going to run through these. You can decide what you like. Some of these are really good even if you're not writing video games. So this is the part to pay attention to if you've been zoning out when you heard the word shaders, which I wouldn't blame you for. Google BreakPad. Crash reports are hard to get from end users. They always send you the wrong thing. If someone else sends me the output from the program strace thinking that's a stack trace, I'm going to murder them because it's never useful information when that stuff comes in, and it's like megabytes and megabytes of text. And when you try to get end users to report bugs, they never do it well, even if they do it at all, but they never do it well. They always report like the wrong things, or they think this thing happened over here, this unrelated error happened, they will focus in on that instead of actually where the crash is, and you never get good information. All you really need if you're a programmer is the stack trace and nothing else. In fact, less human interaction is better than more when it comes to bug reporting. Google BreakPad automates that because, like I said, end users will not report bugs to you. What they will actually do is see the program crashed and load up their favorite web form and talk about how your program sucks, which is not helpful to anyone, you know, but it probably doesn't even make them feel better because the program's still crashing. What Google BreakPad does is when you run, there's a little library you put into your program, and when your program crashes, the BreakPad part will catch that, gather all the important information like the stack trace, what the registers had in them at the time, some other stuff like that, and it will upload it to your server. And you can say things like, well, this program has crashed very little except for people living in Toledo, Ohio. or something like that. Maybe it's something about like the altitude out there or something, I don't know. But it gives you all these metrics and stuff. You run it on a server. This is being used by big name things, like not the least of which is Google, but things like Firefox, Mozilla, Thunderbird, the Mozilla Corporation uses Google BreakPad, and anyone who uses Firefox knows that shit crashes all the time, right? Oh, there's too many Firefox people in here. Okay. Last time I was talking to everyone like Google Chrome. I don't know. You're not going to throw anything. That would be good. Okay. So anyway, so this can handle literally tens of thousands of crash reports at a time and millions in a database, so you can get metrics on what's going wrong in your program and what is a one-off bug versus a serious bug that's happening to everyone. It's worth looking into. You do need to run it on your own server, though. It's not like Gmail, where you just go to Google and they give you a BreakPad instance or something, so keep that in mind. Valgrind, which I used to think was pronounced Valgrind, but apparently it's Valgrind. Which I think is a Norse god or something like that. Has anyone used this program? This program is fantastic. This program has saved my life so many times. What this basically does is you give it a program to run at the command line, and it runs it in a little virtual machine. So every instruction that it runs, every x86 instruction it runs, it makes a note of when it touches memory, when you freed memory, when you've stepped over a memory buffer, when you've done any other number of things, when you've blown your stack, when you've touched memory you haven't initialized yet, and it'll say, whoa, dude, at this exact moment, you used a variable that you forgot to initialize, which came from over here, which was touched over here, or was freed over here before, or something like that. It gives you all sorts of metrics. The only downside to this thing is it runs really, really slowly. And their optimistic example on their website is that it runs your program about 16 times slower, which I think is really optimistic. I would say it's probably more than that. And that's not a big deal if you're writing Microsoft Word, because that shit is slow already. Am I right? Okay. Hey, thank you, I'm here all night, tip the waitstaff. But it's really, really hard when you're running a game, and especially when you're running a game where the frame rate is so low because of this that it's hard to get to the part that you want to debug something in. But if you're willing to persevere through it and stumble until you can get to the point, it'll almost always show you exactly where your bug is. If you write C code, you need to download this tonight as soon as you leave this talk. If you write C++ code, same deal. If you write anything that's native code, if you're using a scripting language or something like that, like Python or Ruby, this will probably do you less good because it might show you bugs in the Python in Python.exe. It'll show you Java virtual machine bugs, but it won't show you your program's bugs. But this is very interesting. This has been ported to Mac OS. For anyone that's played with this, you can use this on Linux or Mac OS. This does not exist on Windows and probably never will. I've told people many times that if you're a game developer and you have no intention of shipping on Linux, you still need a Linux version so you can use Valgrind on it, because it will find bugs that if you don't find them with Valgrind, your customers are going to find them for you, and then you're going to need Google BreakPad. But this thing now runs on Mac OS, and it showed something very eye-opening. Your little Hello World program will trigger hundreds of bugs in Mac OS system libraries even before you get to the main function. So, when everyone tells you how secure Mac OS is, they haven't really looked for buffer overflows yet. So, keep it in mind. Speaking of debugging, who's heard of GDB? I'm telling you, the C programmers are on that side of the room. They're like, oh yeah, I know that. If you're debugging native code, that's the other thing. Valgrind doesn't actually need the source code. It only needs the binary. If it has debugging information in the binary, that's better, but it can do it without it too. GDB is the system debugger for Linux, among other systems. GDB 7 is the newest version. They're up to like 7.6 now or something. I don't know what version. There's a new feature they added in this called reverse debugging. For those that haven't heard of this, it's TiVo for debugging. And the way that you normally debug stuff on Linux is or in anything, in any debugger, is you know there's a crash, so you try to get the debugger to run the program as close to that crash as possible without actually crashing, and then you step up to it slowly. Yeah, and you guys are joking, but that's exactly what you do. You try to step up to it slowly and see what's going wrong. Inevitably, you step too far and it crashes, and that's like, well, shit, I guess we'll start over. And that is the way of the life of the programmer. You spend your whole life debugging, not programming, which I didn't know when I first started programming. But there's a better way, and GDB 7 has it, and they call it reverse debugging, which is to say you run the program until it crashes, and then you back up. And it's just like rewinding television with TiVo or something like that. You literally go, okay, it crashed here. Let's move back a line of code. Let's move back a line. Oh, that variable is totally wrong. Now I know where it is. So something that could have taken you forever to track down, now you just go till it crashes and step back a few lines and go, oh, there's the problem, and then life goes on. This is still a work in progress, even though we're halfway through GDB7's probable life cycle. It can only when you turn this on, it gets incredibly slow, slower than Valgrind, and it can only hold so much data because it's literally looking at each opcode, I think, and saying, okay, we added something to this piece of memory, so when we step back over, we'll subtract, I don't know, or something like that. I don't know exactly what it does, but you have a certain amount of metadata it can hold in a buffer, and it takes forever to move any length. So you still need to get fairly close to your bug, but you can still step backwards from there. I have a feeling over time that will improve. It's probably improved since the last time I looked at it, but that will be the future for debugging sooner or later. Now, as for the future of compiling, there's a program called Clang. I'm not even going to ask who's used this because the C programmers are all over there. Clang is a C compiler. It's currently being largely paid for by Apple. Don't get nervous, it's an open source project. It's built on top of a framework called LLVM, which is being used for everything, including, I heard someone talking about today, somebody's got LLVM processing old school Nintendo Entertainment System binaries and turning them into x86 code, so they're just native Linux binaries. So you just play Super Mario Brothers as a native Linux binary, which is great. Build on top of that technology. Clang has a nice feature that GCC doesn't have because GCC has a problem that it's like 30 years old now, and you start to find that a 30-year-old program, you can't really improve things, you can just keep bolting shit onto it. That's true for any language, not just C. But Clang, since they had this clean code base, they could go for certain goals that no one had thought of yet, such as static analysis. Clang has something called static analyzer, which is to say you give it your C or C++ source code, and it finds your bugs before it compiles. And I don't mean like the way you would with GCC, where you get -wall, and it says, hey, we think maybe you didn't initialize this variable. Static analysis is incredibly hardcore stuff. It'll be like, this is not initialized if you go through this path, because over in this function you might have gone through this else statement. And I have not yet seen a program, a piece of C or C++ source code push through this that didn't find a legitimate bug that nobody knew about for decades. SDL, which is the project I talked about at the beginning of this, we ran it through Clang Static Analyzer last year, and it found 176 errors in code that was compiling clean with all warnings enabled. And it was really eye-opening, because a lot of it's like, no, that's not, oh, it is a bug. Oh. So it's finding things that not only will the standard warnings not find, but the human eye will not find either, because it can hold lots of information the human brain can't hold all at once. So having put code that we think, when we write SDL code, we think the angels are singing a chorus behind us. We think we're just writing this magical code, and we run through Clang, and it's like, here's 176 places where you just straight up fucked up. So when Valgrind first came out, it was used very heavily by the KDE project, and you saw this whole flood of commits of, Valgrind fixed, Valgrind fixed. Little things where it's like, we didn't even know we were overflowing a buffer so far harmlessly until it ceases to be harmless. But, as we're starting to push every piece of the millions and millions of lines of C code that make up your average Linux distribution through Valgrind, as we've been doing for 10 years now, or probably close to it, as we've done that, we started to get a better code quality across all open source projects and closed source projects for that matter. And when it first became useful, there was this whole flood of commits across all these open source projects of buffer overflow fix, uninitialized variable fix, et cetera, et cetera. Clang Static Analysis does the same thing, except you don't even have to compile the program to find them. So that is totally worth checking out, even if you're still going to use GCC. The other benefit of Clang, much, much faster than GCC. I know a lot of people that are using Clang for development stuff because it can compile stuff 3 times as fast as GCC can. And they're still using GCC for the final binaries they ship. That won't be true forever, though. All right. I don't know anything about Blender. I'm not an artist. It's a 3D modeling tool. Think of Maya or something like that. This used to be closed source, and then they open sourced it, and there's a whole lot of interesting history behind it. I've never used it because I have no artistic skill whatsoever. I've heard a lot of things about it. It's got really nice Python integration if you want to do some custom tools built on top of it, which is always great. But I've also been told by artists it's kind of like using the GIMP instead of Photoshop. It can get the job done, but it's not what the professionals use at this time. Someday I'm going to give this talk, and that may not be true, but right now it is. But that being said, if you're using 3D Max or Maya or something like that, they're incredibly expensive. And this is incredibly free. So sometimes that's all you need. I'm almost out of time. I'm going to get through the rest of this real quick. Getting Mercurial. Who's not using source control in here? Yes! This is the first time I've given this talk where nobody raised their hands. Who's using Subversion still? Well, okay. You should not be using Subversion anymore if you're using it. Is anyone using CVS? Okay, you need a new job. If you're still using Subversion, it's time to move on from it. If you're still using CVS, it's time to move on from that job because your employer's a shithead. There's no reason to be using CVS at this point. I don't have time to get into all of why distributed version control is important, but it's incredibly important. It's incredibly empowering. Even if it's just you sitting in your bedroom with your computer and nobody else ever intended to see this, these projects will still save your life. You will be surprised the number of times where just being able to see what you've done and have a nice revision history for that will save your life. Yes?
Does anyone actually still use Mercurial?
I use it. I love Mercurial. I hate Git. I get that question too. Both of these are fine. Mercurial has less of a learning curve. Git is probably more powerful. You can decide what's right for you. I happen to like Mercurial. Both work great. The important thing to take away from this is that one of these two is good, almost anything else is bad. If you're using Subversion, take a few minutes to learn one of these two, take an hour to learn either of these two, and you're just gonna, it's one of those things like, you know when you used to use web browsers and you had like 15 windows open and then someone said, hey, let's put tabs into this one window? You know how that like changed your life and you didn't even know you needed it and now you can't imagine not having it? That's what this is versus Subversion, so question. I don't know much about Bazaar. I mean, you could probably, the distributed part is the magic word here, distributed version control. Bazaar is probably fine too, but you know, one of these is probably your best bet. Now, the whole package. I know a lot of you are saying, I don't want to build tools. I'm being told 2 minutes. Okay, I'm going to go through this very quickly. And if you don't want tools, if you want a whole engine, here's a couple of game engines you can look at. IO Quake 3 and IO Doom 3 are based on the GPL releases of those games from id Software. We've done a lot of work on at least one of those two to make it more modern and add features to it without changing the gameplay. Ogre's a 3D game engine. Dark Places is actually, believe it or not, based on Quake 1 and is more powerful than Doom 3. They spent an enormous amount of time making that thing great, and they've shipped commercial games on top of it. Cube is actually where that ENet library came from. They call it Sauerbraten now. It's interesting and worth checking out. If you want a 2D game engine, HGE, which stands for like Half's Game Engine or something like that, is a nice, simple way to get a 2D game up and running. All right, the picture of my kid running down the train track says we're out of time. Thanks, Olive. So that is all, folks. If you have any questions, I'll take them now. You can hire me. These slides are up at ikkiels.org/self2013. That's my email address, my Twitter account, my Google Plus account. And if you're using Facebook, man, you got to reevaluate your life. Okay, questions? No questions? I got time. Yes?
Have you ever used SFML?
SDL? He asked if I've ever used SFML instead of SDL. I have used it, not commercially. I've just played around with it. I find that SDL is a nicer library. SFML tends to be more of a kitchen sink. Like they're throwing in a lot of stuff you need, whereas SDL is a lot lower level. It's hard to explain this to non-programmers, but the programmers in the room will understand. I like the way SDL feels better. You know, it's like there's a certain feel to the way that various libraries are to work with, and I just like SDL better. Also, I think, if I recall, SFML is C++. You can, which is fine. Almost everything uses that now. SDL is C, and it can be called from C programs without any tap dancing. Question?
Have you used Pygame?
I have not used Pygame because I think Python is awful, but that's just me. I love my white space, you know, whatever. But Pygame uses SDL behind the scenes, and a lot of people have built really fun, interesting things with it. It's just not a language I personally enjoy, and nobody's paid me to work on it, which is always the greatest motivator of all. But there's nothing wrong with Pygame if you like Python. Question? What about what? Allegro? I don't really have any experience with it. Back in the 90s, there was a real, or the early 2000s, there was a real competition between SDL and Allegro. Again, I think it was the same thing, kitchen sink stuff, and I don't have much experience with it. I can't really say. I would say that chances are, if you ask people what the de facto standard is, they're going to tell you SDL. But do look at options, and if you find something better, email me and tell me I'm wrong. Question?
I was wondering, what was that first engine again?
Oh, that's IO Quake 3. There'll be a link to it up on the site. It's Quake 3 with an I and an O in front of it. Yes, question?
Links to the slide I wrote, just FYI.
Apparently you cannot get it, but I will fix the link as soon as this talk is over. Thank you. Any other questions? I got a couple of seconds left. I can go over time. I don't even care. I do what I want. No questions? OK. I talked really fast for nothing. Now I will sing a song for you. OK, I think we're done. OK, if anyone has any questions, I'll be around. Thank you. Oh.
What kind of speed do you take to talk so fast?
It's just pure adrenaline, that's all. So, thank you.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and the administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers, then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication from Wicked.